Okay, so we're going to take a look at this, which is sometimes called vertex form for an absolute value function. So it's vertex form. And the reason is you can actually get the vertex directly from this equation just by looking at it. The vertex actually is HK, which will make more sense as we kind of go through this. But I want to talk about what each one of these numbers here, A, H, and K, do to your parent function. So it might be helpful actually to start with what your parent function is for an absolute value. And that's this guy. Looks like this, right? And then it's a V-shaped graph that goes through the origin. And that is because, like if I was to do, kind of old school, and do my little t-chart, if I plug in 0 for x, my output is 0 because the absolute value is 0, 0. I do that for positive numbers. They all end up matching 1, 1, 2, 2. If I plug in some negative numbers, the absolute value of negative 1 is 1. The absolute value of negative 2 is 2. So that gives me these series of points, right, which will look like, 1, 1, 2, 2, negative 1, 1, negative 2, 2. This graph isn't great because there's really no scale on it, but there, we got some actual scale on there now. And then if I connect these, it gives me this really nice little V shape, right? All my outputs are positive. All my Y values are positive, which makes sense because the absolute value function basically makes a number positive. And so the question becomes then, what happens if I change this number out here from 1? We don't see it, but right now there is a multiplier there of 1. It's 1 times the absolute value of x. So we're going to talk about here what happens when our multiplier is not 1, when a is a number other than 1. Well, the three things that can happen is that you can get a vertical stretch, a shrink, or a reflection. So we'll talk about them kind of individually. A vertical stretch is when the absolute value function is going to be really tall and skinny. And that happens when it's growing really fast. So that happens when A is a big positive number, right? So that's when A is greater than 1. Now, technically speaking, it's the absolute value of A because we're kind of, we're going to take the negative into consideration later. So really we're just thinking about this number and kind of ignoring the sign. If it's bigger than 1, then it is going to vertically stretch out your graph. It is going to make it grow taller. It's like going to take this guy and pull it out and make it tall and skinny because all of your outputs are going to be 5 times as tall as they would normally if A is 5, right? Okay, so this happens with kind of a big number, which isn't the best mathematical definition, but it's sort of handy for helping us understand. If this number is big, you're going to get a vertical stretch. A vertical shrink happens when this number is between 0 and 1, like it's a fraction. What's going to happen is instead of being tall and skinny, it's going to grow really slow. So my absolute value V is going to look really wide. It's really slow to get there. It's actually being vertically compressed. So it's a shrink. What basically happens is if the A value, the multiplier out in front, is now between 0 and 1. And again, technically it's the absolute value because we're going to kind of ignore the sign for right now. So if you're looking at this number in front as a fraction, then it's going to give you some kind of shrink. So kind of a fraction out front will give you your shrink. The reflection happens when that multiplier out in front is negative. So this is where the sign comes into play. If your A is less than 0, if the multiplier out in front is a negative number, then it's going to reflect upside down. Then your V is going to go this direction instead of pointing up. Okay, so this we can write it's a reflection if A is negative. Okay, so that's what the A value does out here. It's going to either give you a stretch, a shrink, or a reflection. The next thing we're going to talk about are H and K. Okay, so the H value, that's the value that we get when we're adding and subtracting inside the absolute value bars. That's going to give you a horizontal shift. It's going to either move it left or right. So if A is greater than 0, it's going to move it to the right. Now here's what's really confusing on this one. Subtraction is part of the format. So technically if we have a H as a positive number, Like if my H value is 5, it's going to, in the equation, look like x minus 5. You're going to see what looks like subtraction, but subtraction is part of the format. So this is actually a value where H is 5. It's a positive number. This is actually shifting 5 units right. So conversely, if our H value is less than 0, if our H value is negative, then we're going to go ahead and move left. But here's what's a little bit confusing here is because subtraction is part of the format, if my H value is actually a negative 5, then it becomes x minus a minus 5. So in the equation, it looks like plus. But this is actually a negative value of h because in order to make it subtraction, which again is the format, then we need it to be a minus minus 5. So this is shifting left. This is actually a negative h value. So what that does to this guy, right, is it's going to move the vertex to the left. If your h value is negative or positive, it's going to move it off of the origin. This V will move left or it will move right. And then the last thing we can look at is our K value. This is actually the easiest one. K is the value being added or subtracted on the end. So this would be something like if you had, g of x equals the absolute value of x plus 2. This is taking my absolute value V and it is going to just shift it vertically. So if I had this a function, what it would look like is this orange piece would just move up 2 units. My vertex would then go up there to 2. And the nice thing about this one is this one's much more intuitive. If you have a plus k up here, it's just going to be up k units. And if it's a minus k, then it's going to be down k units. So it'll take the whole V and just pick it up and move it left move it up or down, depending on whether or not it's positive or negative. So if we kind of put it all together, then we got an equation sort of like this. Y equals 2 times x minus 3 plus 2. We have 3 transformations happening here. First thing we have is our A value is 2. So it's positive, so it's not going to flip upside down, but it's greater than 1. So this is a stretch by a factor of 2. It's going to be 2 times taller. Now the next thing we see here is my H value. My H value is actually 3. Remember, minus is supposed to be part of this format. So this is actually a positive H value of 3. So this is going to actually shift 3 units right. And then I have a K value here, and my K value is 2. So this is going to pick up that parent function, that V function, and it's going to shift 2 units up. So this whole thing is going to get narrower and skinnier, and then we are going to shift it 3 units right and 2 units up. And I'm going to show you what that looks like here. I think I need to write the whole thing again below. So this is going to be y is equal to 2 times x minus 3 plus 2. Okay, so we have shifted 3 units to the right. So we'll go ahead and mark that. From the origin, we're going to go 3 units right. And then we're going up 2 units, up 1, 2. So this is the location of my vertex. It is going 3 units right and 2 units up. So my vertex is 3, 2. My vertex, by the way, is always HK. The vertex is always going to be whatever my HK values are paired as a coordinate. 3 units right, 2 units up, 3, 2. There it is, 3, 2. Now my stretch is 2. That's my growth essentially on the right side. So I'm going to take a slope of up 2, right 1. I do these kind of tiny, so I'm going up 2, right 1. I'm going to do it again, up 2, right 1. And that's what's happening on the right side of my absolute value function. On the other side, because it's symmetrical, I'm going to reverse it. I'm going to go up 2, left 1. And then up 2 again, left 1. I'll make these dots a little bit larger. So that is my absolute value function with all of the transformations. Stretch by a factor of 2, shift 3 units right, shift 2 units up, vertex at 3, 2, There's the visual to go with it. All right. Hope that's helpful. Message me anytime.